Notwithstanding, Europa's surface is befuddled by dark, straight cracks known as linea. These breaks, which stretch for vast numbers of kilometers, are believed to result from tidal forces applied by Jupiter and its many moons. The consistent flexing and extending of Europa's icy crust may create sufficient heat to maintain a subsurface ocean, which could serve as a potential habitat for life. Ongoing observations by the Hubble Space Telescope have provided compelling evidence for the presence of water vapor plumes emitting from Europa's surface. If these plumes are confirmed, they could offer a direct method for testing the Moon's subsurface ocean, bypassing the need to bore through the thick ice. This discovery has rekindled interest in investigating Europa and has led to the development of new missions aimed at exploring its potential for life. Among these missions, NASA's Europa Clipper stands out as a leading effort to study Europa up close, scheduled for launch in 2024. The Europa Clipper will perform multiple flybys, getting as close as 16 miles to the Moon's surface. Equipped with a range of scientific instruments, including cameras, spectrometers, and radar, the spacecraft will map Europa's surface in exceptional detail, looking for signs of subsurface activity and potential landing sites for future missions. In addition to NASA's Europa Clipper, the European Space Agency, ESA, is planning its own mission to explore Jupiter's icy moons, known as JUICE, Jupiter Icy Moons Explorer. This mission will focus on examining Ganymede, Callisto, and Europa in detail, and is scheduled for launch in 2023. JUICE will enter orbit around Ganymede, becoming the first spacecraft to study a moon other than Earth's. Both the Europa Clipper and JUICE missions hold the potential to revolutionize our understanding of Europa and its potential for life. By examining the Moon's surface features, analyzing its subsurface ocean, and investigating its chemical composition, these missions will provide invaluable insights into Europa's habitability and the possibility of life beyond Earth. Looking ahead, the exploration of Europa holds promise for answering some of the most profound questions about the origins of life in the universe. If life is found to exist beneath Europa's icy crust, it would have significant implications for our understanding of the prevalence of life in the universe. It would also raise new questions about the nature of life itself and its ability to thrive in extreme conditions. As we await the arrival of the Europa Clipper and JUICE missions, excitement continues to build within the scientific community and among space enthusiasts worldwide. The prospect of exploring a world with the potential to harbor life is truly exhilarating, and the discoveries awaiting us on Europa are sure to captivate the imagination for years to come. Europa remains a beacon of exploration and discovery in our solar system. Its icy surface conceals a world of hidden wonders waiting to be explored and understood. With new missions on the horizon, we are on the verge of unlocking the secrets of Europa and unraveling the mysteries of its potential for life. The journey to Europa promises to be one of the most awe-inspiring chapters in the history of space exploration, and the discoveries that await us are sure to inspire wonder and amazement for generations to come. Europa, one of Jupiter's Galilean moons, has captivated the imagination of scientists and the public alike since its discovery by Galileo Galilei in 1610. Its smooth, icy surface hides a subsurface ocean that may contain more than twice the volume of water found on Earth. This hidden ocean, warmed by tidal forces generated by Jupiter's gravitational pull, presents a tantalizing environment for microbial life to flourish. Europa's surface features, including its complex network of cracks, ridges, and icy plains, provide important clues about the Moon's geology and internal processes. The dark, straight cracks known as linea are thought to result from the flexing and stretching of Europa's icy shell, driven by tidal forces from Jupiter and its other moons. These cracks may act as conduits for material from the subsurface ocean to reach the surface, potentially transporting fluctuating signs of subsurface activity. In addition to linea, Europa's surface is marked by puzzling features known as lenticula or spots. These features, ranging in size from a few kilometers to several kilometers across, are thought to form as warmer ice from below rises to the surface, creating domes, pits, and other distinct shapes. The presence of lenticula suggests that Europa's icy surface is dynamic and actively renewing, a process that may help sustain the Moon's subsurface ocean over geological timescales. Later observations by the Hubble Space Telescope have provided compelling evidence for the presence of water vapor plumes emanating from Europa's surface. If confirmed, these plumes could offer an indirect method for testing the Moon's subsurface ocean, providing valuable insights into its composition and potential habitability. Future missions to Europa, such as NASA's Europa Clipper and ESA's JUICE mission, will be tasked with studying these plumes in greater detail and assessing their significance for astrobiology. The search for life on Europa is driven by the realization that wherever there is liquid water on Earth, there is life. From the deep-sea vents of the Mariana Trench to the frozen depths of Antarctica's subglacial lakes, life has proven remarkably resilient in extreme environments. If life exists on Europa, it may resemble the microbial communities found in Earth's own oceans, thriving in the cold, dark depths beneath the ice. One of the key challenges in exploring Europa's subsurface ocean is accessing it without contaminating it with earthly microorganisms. Any spacecraft or lander sent to Europa must undergo rigorous sterilization procedures to ensure that it does not introduce terrestrial life into this pristine environment. This challenge underscores the importance of international cooperation and adherence to strict planetary protection protocols in the exploration of potentially habitable worlds. Looking ahead, the exploration of Europa has the potential to transform our understanding of the habitability of icy worlds in our solar system and beyond. By studying Europa's geology, chemistry, and astrobiology, scientists hope to unravel the mysteries of its hidden ocean and determine whether it could support life. The discoveries made on Europa will not only shed light on the origins of life in the universe but also inform our search for life on other icy moons. In summary, Europa stands as a testament to the boundless potential for exploration and discovery in our local solar system. Its icy surface hides a world of wonders waiting to be explored and understood. As we embark on the journey to Europa, we are driven by a sense of awe and curiosity about the mysteries that await us beneath its frozen exterior. The exploration of Europa represents a significant step forward in our quest to understand the origins and evolution of life in the universe, and the discoveries that await us are sure to inspire wonder and awe for generations to come. Rising ice emitted through the surface, while the confused, unpleasant lenticula could be shaped from little, broken parts of the hull implanted in dull ice from beneath, seeming like chunks of ice in a frozen ocean. Recent studies have found that these secretive highlights may sit above huge pools of fluid water that are altogether encased inside the frosty external shell of Europa. This broke external shell is estimated to be mostly water ice, frozen as hard as rock and around 15 miles thick. Yet these lakes may not be the only assortments of water Europa is covering, because underneath this thick frigid shell, researchers have also tracked down evidence of an immense subsurface global, pungent sea. Europa's most striking feature, dim, bungling direct breaks and edges that stretch around the Moon, is called linea, which is Latin for lines. What caused these breaks is still a mystery, but they are possibly thin spots inside its ice hull, which are being impacted by Jupiter's gravity and the other Galilean moons. The frigid Moon gets extended and released by the pull of Jupiter's strong handle in a perpetual cycle as Europa circles the giant planet. This crushing in and out is a cycle called tidal flexing, which might be causing these giant fractures and edges. The tidal flexing may also be generating enough heat inside Europa to keep a fluid sea beneath the Moon's frosty surface. The breaks aren't deep, expanding voids, but rather have all the earmarks of being filled in with dark material, suggesting that some of them might have also been caused at least partially by the sea beneath. Researchers tracked down that the patterns of some of the longest fractures didn't fit expected patterns of breaks that should be made by tidal flexing as Europa orbits. Still, it was determined that the patterns fit well overall. However, if Europa's surface could move independently and was not locked to the rest of the interior, such as if a layer of fluid existed between the outer shell and the Moon's rocky mantle, another piece of evidence for Europa's mysterious sea is measurements that Galileo made during its various flybys. Galileo identified that Jupiter's strong magnetic field was being upset in the space around Europa, strongly implying that a unique kind of magnetic field was being created deep inside the cold Moon. And researchers think the most probable reason for this baffling magnetic signature is a global, salty sea. What's interesting is that we might have already seen the water from this mysterious sea escaping into space. Astronomers using the Hubble Space Telescope have imaged what could be water vapor plumes emitting off the surface of the frosty moon. If this is water vapor, then it increases the chance that future missions to Europa might be able to test its sea without having to bore through the hard ice. So, what are these puzzling, spot-like features observed on Europa's surface? Well, there is solid evidence that beneath its frozen outer layer, huge pockets of water exist, and alongside much more evidence, those pockets might be sitting over a covered global, salty sea that contains potentially several times as much water as all the water on Earth. Why is this truly astonishing? The likely revelation, anyway, is that researchers imagine that Europa's subsurface sea could be the best spot to search for life beyond Earth. Due to Jupiter and the other Galilean moons pulling on Europa, its ocean floor could be warmed by constant tidal flexing, driving aqueous movement like undersea volcanoes in Earth's sea. For example, it is possible that with the right elements for the chemistry of life under the ice of Europa, it very well may be livable. With this tempting evidence, Europa is quite possibly one of the most exciting spots in the planetary system to explore, and we have 2 future missions to anticipate. The first is NASA's Europa Clipper spacecraft, which will perform many close flybys, researching whether the frosty moon could have the right circumstances for life. The spacecraft will pass the moon as low as just 16 miles over the surface, rising above various areas during each flyby, and is estimated to launch in October 2024. We haven't got long to wait for this mission to start, but we do need to wait some time until we start seeing the results, since Europa Clipper will not arrive at Jupiter until April 2030. The second mission we can look forward to is ESA's JUICE, Jupiter Icy Moons Explorer, spacecraft, or Jupiter's Icy Moon Adventurer. JUICE is designed to observe Jupiter and 3 of its large moons, Ganymede, Callisto, and Europa. ESA plans to enter JUICE into an orbit around Ganymede towards the end of the mission, becoming the first spacecraft to orbit a moon other than Earth's moon. The spacecraft will launch in April 2023 and arrive at Jupiter in July 2031. The 2 missions will bring fresh new perspectives on this strange moon and potentially confirm that it does have a global, salty sea beneath its ice that could support life as we know it. The mid-2030s will be an exciting time for space exploration. Investigating the baffling moon Europa has long been a tempting possibility for researchers and space enthusiasts alike. Its frigid surface, marked by perplexing patterns of cracks and streaks, indicates a world of hidden wonders beneath. As our understanding of Europa expands, so does our curiosity about the possible outcomes it holds. Europa's surface features, including its baffling spots and dark, linear cracks, provide valuable insights into its composition and history. The presence of these surface peculiarities suggests dynamic processes at work beneath the moon's icy shell. Understanding these processes is key to unlocking the secrets of Europa's potential livability. Quite possibly one of the most convincing bits of evidence for subsurface activity on Europa is the presence of lenticula, or spots, dispersed across its surface. These features, ranging from smooth domes to rough pits, are believed to form as warmer ice rises from underneath and interacts with the colder outer surface. The uniform size and shape of these lenticula indicate a common origin, perhaps tied to the movement of subsurface liquids.